Hey guys, I was toying with the idea of being a self-taught developer back in 2018, but I dropped the idea because I was crushed by the incomprehensible amount of jargon used by developers. I mean, like, why do you guys use so many buzzwords? Anyway, fast forward to 2019, and here I am, giving programming another go again because I really like the idea of being a software developer. It pays well, it is in demand, and I get to live the casual lifestyle I crave for. And look at some of the perks offered by this company I've set my eyes on. Open work culture, too many birthday cakes, an abundance of bad puns and dad jokes. This casual yet high-tech environment is what draws me to software development. After 6 months of research, I finally come up with a plan on how to be a software developer, and in this video I would like to share those plans with you. Let me start with my background and the challenges I currently face. I'm a part-time math tutor in Vancouver. I have $1,000 set aside for this venture. I have a young family with a toddler and a baby to care for. I have only 2 to 3 hours a day to code. I'm 38 years old this year. And I have no computer science qualifications. I hope you're in a better position than I am. Next is to decide on the kind of software developer I want to be. I want to be one that is high in demand, has plenty of job opportunities, pays decently, and one that has low entry barrier for people like me. Only one developer job fits all my needs. A web developer. To better understand why web development is a good choice to pursue, let's head over to Stack Overflow's 2018 Developer Survey results, which gives us a glimpse into the software industry. The largest pool of developers come from companies involved in web design. There are thus plenty of job opportunities. And web developers are hired based on the technologies they specialize in. You have front-end developers, back-end developers, and if you can do both ends, you are a full-stack developer. Understandably, web developers are in demand and their numbers dominate the industry. High in demand job? Check. And while we are at it, let's look at how technologies are clustered because developers are expected to know a lot of them. Unfortunately, what's shown in this map is not exhaustive, as there are many important tools not shown. To be a web developer, I will need to be proficient in both front-end and back-end technologies represented by the central and lower left clusters. That's right. Ultimately, I would like to be a full-stack developer. Since I've talked about both front-end and back-end work, I would like to use my favorite web application, Desmos, to illustrate the difference between front-end and back-end work. Front-end developers pair with web designers to create beautiful web interfaces for users to interact with. Functionality and aesthetics, performance, and support for devices with different screen sizes, aka responsive web design, are some of the things front-end developers concern themselves with. However, it is the back-end where the magic that powers our web application happens. The back-end consists of huge computers known as servers that are capable of processing and serving massive amounts of data to thousands of users. The brunt of processing and the logic that are required to glue and run many services together takes place at the rear end. I think I'm more of a back-end kind of guy, but since there are more front-end jobs than there are back-end, I'll most likely be applying for front-end job initially before moving on to back-end. And hopefully in the future, I can do both front-end and back-end as a full-stack developer. Let's check out the global average salary for developers. You have front-end developers, back-end developers, and full-stack developers. Very decent if you ask me, since the figures are quoted in US dollars. United States. Very high pay. Check. Job opportunities is another factor I seriously considered when deciding on the type of developer I want to be. This is crucial because I do not have the luxury of uprooting my entire family to search for jobs. According to Indeed, there are more than 800 plus web developer jobs available in my area, and many of them with 60K annual salary onwards. Glassdoor listed even more jobs in my neighborhood. Plenty of job openings? Check. With plenty of job openings, I can really do crazy things like send out 450 resumes in my area. I should get at least 10 interviews. Or 5. Come on! Well, The good news is you can work as a software developer even if you do not have a computer science qualification. Take Triple T job postings for example. If I'm able to showcase a portfolio to demonstrate my coding skills, they should give me a chance for an interview. At least that is what they ask for in their requirements section. Accepts non-computer science graduates? Check. To recap, web development is the way to go for me because it is ubiquitous, in demand, and future-proof. I can work in almost any industry of my liking, provided the company has a website. There are plenty of job opportunities for developers of different proficiencies, ranging from WordPress developers to full-stack unicorns. The pay is good, and I find it fun and exciting to work with web technologies. My strategy to be a software developer is fairly straightforward. Number one, get good resources, and number two, create a structured curriculum to follow. Unfortunately, as far as resources goes, both boot camps and part-time courses are not an option for me because they are way too expensive and time-consuming. And I can't learn well from watching online videos as well. So that rules out fantastic online platforms like Udemy and Codecademy. I have nothing against online learning, by the way. That's just me. I suck at learning via videos. I learn better with written material, so that means plenty of books and online articles and documentations. So those are my resources, just books and articles. But feel free to use whatever resources to help you progress to be a developer. Every one of us are different, so go for the method that suits you best. As for what I should learn, I have created a curriculum that is divided into 5 separate stages. Stage 1 is to learn non-negotiable, essential tools and technologies web developers should know. Since I have a Mac running OS X, my choice of development tools will be skewed towards the Unix and Linux ecosystems. And by the way, if you're keen on web development, it will be highly beneficial for you to know a bit of Unix. Well, I'm not going to be sucked into this debate. Of course, Apple is better. No, I'm just kidding. You'll be totally fine in the Windows environment. But the majority of web technologies do run on top of Unix and Linux. As a Windows user, learning Unix or Linux will certainly make you more marketable in the future. It is worth your consideration. Here is my list of non-negotiables, which I've arranged in learning order. First on the list is to touch type. I can currently type 55 words per minute consistently, which should be adequate. Do learn to touch type. Please do not be a packer. A packer. Next is to learn command line. This will make me a super user in the lingo of the computing world. Command line for me is really intimidating because you have nothing but text and there are no buttons to click. But after plenty of research, I found out that if I want to be a competent developer, I cannot escape from using command line. So to save me tons of frustration in the future, I decided to just bite the bullet and learn command line now. Package managers. As a software developer, you need a ton of software installed in your computer. A package manager will ease the pain of installing, maintaining, and updating each software module. Once I've nailed the basics of command line and package manager, I can move on to learning a text editor for writing codes. Which editor is the best editor? Honestly, just shop around and pick the one you like. And whichever editor you choose, it is very important to learn how to use it well. Next in the list, picking my first serious programming language. I'll admit it, this topic is highly polarizing. My personal approach is to make sure the language I learn will be able to satisfy a few important criteria such as, is the language useful for app development? Let me illustrate my first point. Shown on the outer fringes of the mind map are different categories of applications. Will my choice of programming language allow me to create these apps? Let me use the Java programming language as an example. Plain Java, aka vanilla Java, is pretty useless. I won't be able to create these real-world applications, not toy applications, but real-world applications, even if I put in superhuman effort. More realistically, I will need the help of libraries and frameworks, which are codes written by hundreds of other developers to churn out real-world applications. In this regard, Java is actually a versatile language because it has libraries for developers to use. By the way, I don't know a Java library for task automation, hence the question mark. If there is one, please let me know in the comment sections below and I'll get you a coffee when you drop by Vancouver. So Java seems like a pretty versatile language to pick up. But before you get too excited, let me give you a word of caution. Just because Java can be used to create all sorts of applications, that doesn't mean it can do every one of them well. In fact, Java may not be the best language at creating apps highlighted in red. Based on what I've read, alternative languages shown are far superior for creating these apps. The second consideration in choosing a programming language is this: will the language help me become a better developer? Java has resources dedicated to good computer sciencey stuff. I will run through each of these using oversimplified explanations. Programming paradigm is the philosophy by which codes are written. One can loosely equate it to different coding styles with clearly defined restrictions and focus. Data structures and algorithms help you create efficient codes. TDD, or test-driven development, is a structured approach to weeding out bugs. Code refactoring is the practice of rewriting existing codes to make them more readable. Developers should leverage on existing code templates to speed up development time, and that's where design patterns come in. And finally, it would be nice for CPU-intensive applications to be processed faster. This is the area of concurrency and multi-threading. The third consideration in choosing a programming language is this: does the language have cool features? Java, for example, is extremely popular, has plenty of good attributes including the famed Java Virtual Machine, and tons of library available to help churn out apps. All points considered, Java is actually a very good first programming language to learn. So what's my language of choice? Well, this is kind of silly, but it took me just 5 seconds to decide on my first programming language. I picked Python. It can't be helped, I'm a sucker for everything mainstream. According to Google Trends, Python overtook Java in the US back in 2017. Surely thousands of developers in the US can't be wrong, can they? Anyway, that's my lame reason for picking Python. So feel free to pick the first programming language of your choice. Just make sure it's Python. I'll be really interested to know which programming language you'll be learning first. So please let me know in the comment sections below. The final non-negotiables is a file management and version control software. Programmers work as a team to build codes incrementally. They therefore need a clever way to manage all the files and their different versions. It will be very frustrating if the following scenario happens regularly. Hey, here's an update to your file. Wait, what? I've already updated my files. Well, I updated your update. Here, take it. How do you know that my update is not an update to your update? Take it, you son of a... That's all for my list of non-negotiables, and here are my personal choices for each of them. Once Phase 1 is completed, I'll move on to Phase 2, where I'll focus on learning good computer science practices. You might be wondering, where is HTML, CSS or JavaScript and its myriads of frameworks? Aren't these the brick and mortar of front-end development? So why am I not learning them first? Well, it is more crucial at this point to build a solid understanding of computer science principles. Take Programmer A and Programmer B for example. A has good computer science foundations while B doesn't. Using English composition as an analogy to compare their work, B would produce the following work, while A can get the same job done more elegantly and efficiently. In this analogy, A would produce codes that are succinct, human-readable, and functional, while B would write over-engineered codes that may lead to maintenance nightmare. Learning a bit of computer science foundation will not only make me a better programmer, it will give me an edge over sloppy developers. Phase 2 will therefore involve the learning of data structures and algorithms, unit testing, and some recommended programming practices. Phase 2 may set me back by at least 4 to 5 months. Thereafter, I'll dive into front and back-end development in Phase 3 and Phase 4. Phase 5 will probably include the creation of a full-stack web application to integrate all that I've learned, getting a job, and staying in the job for 1 to 2 years. Realistically, I will start applying for front-end jobs in the middle of phase 4. Because even as a front-end developer, I do need to know a bit about back-end and how data is moved between the client and the server. From what I've read, knowing a bit of back-end will help me tremendously during interviews. Thank you for applying for our front-end developer job. Can you please tell me a bit about MongoDB? Mango? No, MongoDB, the non-relational database. Oh, I think this Mongo dude should hang out a bit more often. So, when do I start?